Before I start, I want to make sure each of you got the raffle ticket for the great giveaway we are giving tonight. It's an Amazon Echo Dot. We have a raffle we're giving away after every talk, so make sure you get the ticket. And also make sure you grab some food and beer right at the back there. Cool. Very good evening, everyone. My name is Vikram Hosakote. I'm a software engineer in Cisco's Meta Cloud team. I work in the OpenStack team, mainly working on developing, deploying, scaling, debugging, troubleshooting OpenStack clouds for enterprise, data center, a bit of NFV customers as well. Today's in-booth talk is about why we think Cisco's UCS platform is one of the best or the best hardware to deploy three things, right? Docker, Kubernetes, OpenStack. We've done a lot of development, testing, scaling on Cisco UCS with these three technologies, especially the newer technology, Kubernetes and Docker as well. And we've been working on OpenStack for like 5 years now, like 5-6 years, since almost Cactus 2011-12. I got involved in OpenStack in Diablo Folsom release, almost 2012-2013. And before I start, please feel free to stop me for any questions, and I'll be at the other side of the booth around the corner for any questions. Okay, let's dive in. So today's agenda is first we'll learn what's Cisco UCS. I'm sure most of you know about it. I think most of you know the four what is here, right? I'm just gonna like spend 30 seconds on each of those slides. So we'll learn what is Cisco UCS, what is Docker, and I'm gonna spend some time on the other three bullet points here, right? How we've deployed an OpenStack cloud on containers on Kubernetes on Cisco UCS hardware, and the role of Red Hat, right? We're at Red Hat Summit, so Red Hat is very, very important for us. We're going to spend a lot of time talking about why Red Hat is very, very important for us and work with. Wasn't launched in the market until 2008, and in 2008 started 2009. So basically, it's simple, right? It unifies storage, compute hardware into a single box, right? You have different cards. You want special networking, insert network cards. If you want special storage, you get like special, disks. And if you want special compute, then you have special compute hardware, CPUs and compute hardware, right? So the servers are basically B series, C series, and the S series, the storage. B are the blades, so 1 RU, 1.5 RU blades, and 5108 chassis. It's easy to maintain, easy to insert, easy to remove, easy to upgrade, very easy to ship and unbox and unbox all of that. C series is our flagship C rack server. So it's different than a blade server. It's an entire rack server with the bells and whistles of a regular rack server. And then we have storage server, S series. That's kind of new in OpenStack, please. And it's been around for a while. It's kind of started being used in OpenStack deployments, mainly for storage, object storage, block storage, and then the regular traditional, disks and RAID and all that. And it also does some new stuff, like it abstracts a bunch of disks into API calls for the user, all done on the S series. And in the management software, we have a couple of management softwares used to manage the servers. We have the UCSM, we have the UC Director. We have a plugin that can be used in the APIC GUI as well with the ACI platform. And then some peripheral or optional, non-server hardware, right? So we have Fabric Interconnect that abstracts a bunch of servers up to 64 blades into a single pane of glass. We've tested it to 64 into a single pane of glass using Fabric Interconnect. It reduces the port density. Everything is one-to-one port level south of the Fabric Interconnect, north of Fabric Interconnect. The user just uses a single pane of glass. If the user doesn't know that there are 64 servers connected underneath, it's all kind of abstracted at an API level and in the GUI level in the management software GUI. East's blades, we have the M series, M2, M3, M4, I think is in the development. Adapters, you have PCIe, Cisco UCS, GPUs, rack and power infrastructure. We have rack and power units on there. So this is basically the entire usage range, everything hardware, except disk software. We have full support and the usual SLAs like updates and patches and support and everything. So Docker, I'm sure all of you know about Docker. It's been around for a while. Everybody's playing with it. Cisco also started playing with it a couple of years ago. We took some time to figure out how to use Docker, even internally for beta testing or in production environment. So it's very simple, right? There's no virtual machine. Nobody wants virtual machine these days. Instead of creating 5 virtual machines on a bare metal server, creating 5 containers that run 5 applications on the same bare metal server is far more performant and performance. You see more performance and scale the benefits using 5 containers instead of virtual machines. And we all know that an application doesn't use the entire virtual machine, right, in its life cycle. It just uses a part of the RAM, part of the CPU, part of the disk. It doesn't need the entire virtual machine at all. So this is a container technology, host OS with a daemon with a server, and then siloed, isolated boxes, right? Docker, there's a Docker agent or a Docker client that does the isolation and the application and its dependencies, nothing else. There's no need to worry about if the application works or not in a different environment, because once it's deployed, it will be deployed with all the dependencies that are needed for the application. Examples there are tons of examples like Node.js, MySQL. There's registry architecture where images are pushed. A Docker image is roughly a couple hundred megabytes, maybe a gig, a lot lesser than a virtual machine, of course. And then deploying it, starting it, stopping it, maintaining it is a matter of seconds compared to booting, shutting down, rebooting the virtual machine. Kubernetes. So this is another new technology. It's a layer on top of Docker. So the way we can see Kubernetes is like a captain of a ship, right? That's what Kubernetes means. In Greece or somewhere, maybe Italy, maybe Greece, I think Kubernetes means a captain of a ship. The captain is the final, has the final word. He or she does the ultimate thing. If the ship crashes, the captain dies with the ship. If the ship is successful, the captain is happy at the end of the day. So it's kind of a layer on top of Docker to maintain it. And it's not just fire and forget like Ansible or even Docker Compose. Swarm is not fire and forget, but Kubernetes takes Docker to the next step, right? So containers are not just deployed and they're not forgotten. Kubernetes watches it, maintains it, scales it, upgrades it, and it's a huge, complex architecture. I can talk about Kubernetes all day. The main 35,000 feet view is this. Like any management software, there's a master node, there's a couple of worker nodes. Master kind of like instructs the worker node what to do. And in this case, the master will schedule or deploy containers on the worker nodes. And the good thing about Kubernetes is it's meant for scalable container applications for data centers, and it's built for production use cases. It was internally developed in Google by a tool named Borg, and all Borg did was just deploy and scale and manage and monitor containers every second of the day. The architecture is like there are too many boxes here. There's a master, there's like 2 nodes, for example. There can be a lot of nodes. The master has a couple of components: the API server, controller, manager, scheduler, and then backed up by an etcd database. The node or the worker node is kind of like the worker node in the Hadoop architecture in the sense the worker node is very dumb. It just does what it's told to do, and there's a fallback mechanism. If the worker node doesn't know what to do, it may query the database, or it may ask the neighboring nodes what to do. But basically, it's just what the master tells the nodes to do. The components in the node, the worker nodes are kubelet and kubeproxy, and the networking feature, the networking plugin that spans across or on top of the entire container. So we have the master node, the worker node, and then the networking plugin that networks all the nodes together. And using this, we've deployed OpenStack on UCS, and a way to visualize this for an OpenStack cloud is we still have the same architecture. In the pod runs the container. Pod is the unit of deployment in Kubernetes world. In Docker world, image is a unit of deployment. In Kubernetes, it's pod that's a unit of deployment, and we can also see bunches or collection of pods as a unit of deployment, depending on how we design the architecture. But it's all at the pod level, not container level. And then inside pod or containers, they're separated by C groups, namespaces, IPC namespaces. They have a separate isolated environment within the pod. By default, they all see the same network, same IP address, same MAC address, same socket, same network stack interface, sub-interface, all those. So that's the architecture. And the user has a couple of ways to interact. They can use the GUI, the dashboard, CLI, and the REST API as well if the user wants to do some programming with Kubernetes. OpenStack, another open source project to deploy cloud and data centers. Three main pillars, right? Compute, network, storage. Kind of abstracted API level, horizon. API level and in the GUI level called the horizon, which is the dashboard. And then this hardware here is the Cisco UCS hardware I just talked about a couple of slides here. So I want to spend some time on this. So this is what we did to deploy OpenStack on Kubernetes. So OpenStack has it's known to be called a big tent under which there are a couple of projects. I'm a core reviewer and a core developer of a project called Call of Kubernetes that deploys OpenStack Cloud on containers. And it's kind of like tough to understand all of these. It's actually a different version of this, but kind of massaged with the information needed for OpenStack. So we have the UCS hardware, we have the RHEL operating system, with the Docker daemon, and then the Kubernetes worker node, the components of the worker node, kubelet, proxy, CLI. And then we have each OpenStack service in containers. And the project is called Kala. Kala stands for glue. That means it glues different containers together to form a successful deployment. And at the end of the stack, we have like the OpenStack Cloud and then the customer application. So this entire thing is the node. And then that's the master. Master has a Docker daemon as well. It has the master components, controller manager, scheduler API server, dashboard, etcd, kubeadmin and Helm are new technologies we added for managing Kubernetes images. We deploy using something called as Helm charts, kind of similar to YAML file. We kind of write a spec, and then we use Helm, the Helm tool to deploy what's mentioned in the spec in the YAML file. And then we also use some tools from the Call of Kubernetes project. We use Ansible is outside of Call of Kubernetes. We use Ansible for orchestration. We use a tool called Call Ansible to deploy containers using Ansible. So Kubernetes underneath uses Ansible to orchestrate containers. We use genconfig to fallback or generate default configs, so golden config when a config is bad or somebody tampers with the configuration. Genconfig comes into play and kind of rolls back to the known good golden version. And then configuration file. Out of the box, you get golden working configuration for, I think, 25 services. So these are the core services: compute, network, storage, Horizon and some optional services as well. So you get golden configuration files out of the box as well. So out of the box, it's just a matter of running a few CLIs and running, deploying OpenStack on Cisco hardware. This part is done by our bare metal tool. I'm not talking about that today. That is a separate talk in itself. How Cisco does bare metal bootstrapping. The bare metal tool installs operating system on the servers using Pixie boot, IPMI, the regular DHCP, TFTP boot, all of that stuff. Yeah, this is live with all the logos involved. So we have Paula, that's the new logo we got upstream, I think 3 weeks ago. It's nothing but Ansible plus OpenStack plus Docker plus Kubernetes plus this is the logo for Project Calico Canal. It's the networking plugin to network containers. It's an amazing way to network containers. Out of the box containers are probably networked on the same host. They don't span across the physical server, or even if they do, they by default they don't ping across the server. So we can use a CNI tool to network containers and kind of abstract the physical hardware underneath and treat containers as the networking nodes, and we don't worry where they're hosted on the bare metal servers. We also have a plan in the pipeline to integrate Cisco's CNI tool called Contiv that was given by talk before this presentation by Rohit. We are planning to integrate Contiv in the next maybe 1 or 2 releases. A role of Red Hat. So these are the things we use from Red Hat to deploy OpenStack. We use the RHEL kernel, we use the RHEL operating system, we use RPM's OSP. We are at Liberty, we are planning to move to Utaka. We're very slow, but we're very stable. We use RHEL Docker images. That's kind of new. That's kind of tied with Atomic host, RHEL Atomic. These two are being used widely for Kubernetes deployment. Atomic is like a slim, minimal operating system, read-only. USR bin is mainly read-only. Everything has to be installed in the form of a container, and it comes with Kubernetes and Docker out of the box. It's meant for container applications. And we use RHEL patches and updates as well. The other things we use outside of RHEL are we use Ceph, we use Bugzilla, and of course we use service and support as well from Red Hat. OpenStack upstream, as I said, I'm a core reviewer of Paula. I've been involved in streaming since 2013, 2013. These are all the links that have great information. They are like one of the most popular, project or the links that many companies are using to deploy OpenStack out of the box. They should work out of the box, and we are available in IRC for any questions or issues if any found outside of Cisco hardware. Most of them are tested on Cisco UCS and Nexus. That's the contribution. Of course, you can see Red Hat as a top contributing brand. Cisco is not in this list, unfortunately. We kind of reduced upstreaming 2 releases ago, and we're busy downstreaming, but Cisco is probably after SUSE as far as upstreaming is concerned. And those are the top projects. So as you can see, Paula Ansible is one of the top projects, and Kubernetes didn't make it in the top list last release, but it's actually being contributed this release. And we actually have, including myself, we have 4 developers here in this conference. If anybody is interested, I'm very happy to chat with you and show some working configs and deployments. These are references I use, mostly of streams and Wikipedia stuff. I will be available at the other side of the booth for any questions, and I have given email address and slides. I can send you those. That's it. Thanks a lot.
Vikram, thanks so much. Appreciate it.